a of n is equal to log to the base a of mn, right? Now, something I want to point out to you here. There's no value in front of log to the base a of m. That means the coefficient is 1. And there's no value here. That means the coefficient is also 1. So if I want to apply this rule here, the coefficients of both log expressions have to be 1. So that means I have to get rid of this 3 and I have to get rid of this 2. Luckily for you, what you can do is you reverse this law by bringing the power up top here. So what I'm going to do for this one, yeah?
Hi, Uncle.
So what we're going to do, we're going to bring this 3 up top. We're going to bring this 2 up top by reversing this law of logarithm, right? When I do that, when I carry the 3 up top here, it's going to give me, let me just write it over here, log x cubed plus log z squared. Now what we're going to do, we're going to now apply the laws. So remember, you can only apply the law of logarithm if the value in front of the log expression is 1. So now we have a plus between them. It just means that I'm going to multiply what's here and what's here. So when I reduce this now, it's going to give me log of x cubed z squared. We're multiplying variables, we just write them together. So the answer here is actually B as in boy. So do we follow with that? Follow with that, guys? Any questions?
Can you just go over that one more time? Number
Sure, no
7?
problem. Sure, no problem at all. All right, so let me actually get some blank paper up so you guys aren't confused by the bugger writing. All right. All right, so for number 7, we were given, so we were given 3 log x plus 2 log z, and we're supposed to write it as a single logarithmic expression, right? So let me just make this bigger so you can actually see now. All right, so what I was saying is that if we were supposed to apply our law of logarithms, let me just write those here, log to the base a of m. Or, let me just take out the thingy there. So if we had log of m plus log of n, then we know that all we do is that it's going to give me log of mn, right? Now, what I was pointing out earlier was that if you realize in this law, this is the general law, the value in front of the log values here are actually 1. So the only way in which we can apply this law is if the values in front of them are 1. Currently, the value in front of it is 3 and 2. That means we have to get rid of the values of 3 and 2 here. To do so, we're going to use the law that says log of m to the p is going to be p log of m.
Hello?
Yes. Yeah, we're hearing you. All right. So what we were doing here, so to reverse this, we took the 3, right? And we brought it to the power. So that gives me log of x cubed there. We took this 2 here and we brought it to the power plus log of z squared. So now what I can do, because the values in front of them are 1 and 1, I can now apply the law. The law says that all we do is multiply what's here and here. So this is then equal to log of x cubed times z squared. And whenever we multiply in variables, all we do is just write them together. So log of x cubed z squared, that would be the answer. So does that clarify for you?
Yeah, I understand now. Thanks.
All right, you're welcome. All right, so let's get back to the questions that we were working. All right, so let's look at question 8. So which of the following is not true? So we know that ln of 1 is 0, so this is true, right? Ln of e to the x is x. I'm going to skip over this because this is false, but I want to actually go through the others. negative ln x. So when I look at negative ln x, if you use the rule that we're just looking at by carrying the negative 1 to the power, it's going to give me ln of x to the minus 1. But x to the minus 1 is the same thing as saying ln of 1 over x. So how did I get 1 over x there? So when you have a negative power here, it's simply 1 over x raised to whatever the power was. So this will give me x to 1, which is just x. If I gave you x to the negative 2, it's simply 1 over x raised to the positive power now, which is 2. So in essence, when you have a negative power, it's talking about something of a fraction. You just throw it in the denominator and change the power to a positive. So this is actually true. Here now, we have ln of root x. When you talk about a root, it's actually x raised to the power of a half, right? So what we can do now, so this is ln of x to the half, carry the power to the front, it gives me half ln of x, so this is true. Now, is this true? Well, if you remember the law that we looked at, the log ln, they're all the same thing. So log ln, they're all logarithmic functions. Ln here, so if I had ln x plus ln y, we know by the law of logarithm, then it's equal to ln of xy. This is a trick that we put on every test paper that we try to set. Like I do it every time I set a logarithm quiz or anything like that. It's something that students tend to actually mess up, so we always put it. You cannot, I know that you're very tempted to do this. You can't put this, you can't say ln x then plus ln y. Nope, that's false. It's crap in math. And it's something that we use to trick you guys a lot because we know say it's tempting. So don't be tempted by it. Always remember your law of logarithms here. And remember also that ln of x minus ln of y is going to be equal to ln of x over y. Right? So ensure you can recall the laws. So which of the following best represents the graph of y equal ln x? So I'm guessing here that a part of the course was you were supposed to be able to actually know the standard graphs. So let me just draw the graph of y equal ln x. So the graph of y equal ln x is actually asymptotic. So it has an asymptote of the y-axis. So it starts here, then it goes up and shapes like this. The value that it cuts the x-axis here is 1, and it increases outwards until it gets arbitrarily large. But if you realize here, between 1 and 0, it never touches this part here. It gets closer and closer to the y-axis, right? So once you know your standard graphs, so this is the graph of y equal ln x, you're very good, right? So the answer is down there, but before I go down, I'd also want to show you the graph of the exponential function y is equal to a to the x because it could pop up. So if I give you y is equal to a to the x, then the graph is going to be asymptotic to the x-axis. And probably you're wondering, what does asymptotic mean? Asymptotic or asymptotic means that the graph approaches a line but never ever touches it. So if you realize here for the y equal ln x graph, let me just change the color so you guys can follow. So if you realize here with the y equal ln x graph, just changing the color. All right. If you realize with y equal ln x graph here, guys, it goes down and down and down. And what will happen is that it's as the y-axis gets longer, what's going to happen with this value is that it's going to approach it and approach it and approach it, but it will never, ever, ever touch it. So you'll never get a value that's going to touch this y-axis here. So that's why we call it asymptotic. Now, similarly, for the y equal a to the x graph, the a to the x graph is going to be asymptotic to the negative x-axis. So you realize that as it approaches over there, it will approach closer and closer, but never touch it. And it will go up and upwards here, and it touches the y-axis at a value of 1. So if you were supposed to draw both of them on the same axis, right? I'm doing this because it could possibly be a question. What's going to happen is that you're going to find that one graph is a reflection of the next one. So here, this will be the graph y is equal to a to the x. Let's put that here, y equal a to the x. And over here, I'll have the graph y is equal to ln x. So a popular question that we normally set as instructors when we look at the logarithmic topic is that we'll ask you what is the relationship between the two functions or something like that. Or we'll ask you that one is a reflection of the next one. Through which line? Let me set my. So here you realize that it's just a reflection through the line y equal x. So this is a popular question that you normally see on probably a structured exam paper. So this is the relationship between the exponential function, which is y equal a to the x, and the logarithmic function, which is ln x or something of the sort. So it's very good that you guys can remember this, or it would be good for you to remember it in the case it would pop up on an exam. But the answer for this question that asks you about which graph is y equal ln x, so the answer would be C here, because we know that ln is asymptotic to the negative y-axis, and then it increases upwards further. All right. So these questions are going to require you to actually like reason a little bit, just a little bit, nothing too heavy, right? So let's look at question 10 here. So the general term for the sequence 0, a quarter, 2/5, a half is a to the n equal. So if you know the definition of a sequence, then it helps you, it helps you a lot. So if you remember, a sequence is defined as an, right? But the values of n are n is a member of natural numbers, which means that n can be 1, 2, 3, 4, and it goes on and on. But the most important thing here is that n has to start at 1, right? So that's the most important thing. So if you merge this, when you write out the values of n above it, so this is 1, this is 2, this is 3, this is 4, what we're trying to do is establish a relationship between what we have here for the n values and what we have here happening for the fraction. So if we look at the values, the first one is 0, right? So it's a fraction. So we know that obviously it's a fraction and the numerator is 0, right? But the starting n value is 1. The only way that I can get a fraction to be 0 is if the numerator is 0. So I know that the starting n value is 1, right? If I start at 1, how can I move from 1 down to 0? I'd have to subtract 1. So what we'll have here is that the starting value is 1, and that's n. So I'm guessing that the numerator will be n minus 1. So let's check if that works for all the other values. So in 2 minus 1 gives me 1, 3 minus 1 gives me 2, so that's good. Now you probably look at it and say 4 minus 1 would have given me 3, so how this not work? Well, this doesn't work because this fraction was actually reduced because it had a common factor. So nothing to worry about it there. This is actually the same as 3 over 6. So if we were supposed to write it now, 4 minus 1 would have given me 3, and so it would work. All right? So as I was saying, this is the fraction being reduced because it had a common factor, but it does work. So I know that the numerator is n minus 1. So from that, I know that it can't be A, it can't be B, and what we have to decide now whether it is C, D, or E. So we're now going to look at, we're going to look at the denominators and see if we can figure out the pattern. There's no useful information from the first term anymore. We actually got the answer, or got the useful information from the numerator. But now we have to look at the denominator.